Hmm.
Okay, can everybody hear me okay?
Yes.
See anybody? Okay, thank you. Here. Uh, First, trying to drag this thing so I can see people. Let me stop that if I can. Okay, first thing, your quizzes are back in, they were placed on Canvas, so you should be able to obtain them and see your grade. The second is, I'm sharing a screen now. Can you all see quiz A, 1A here on the sharing site class? I mean, if you can, just let me know. All right, so I want to go through this. There's two quizzes. They virtually cover the same material. They were designed to be extremely easy if you understood the material, but if you didn't, it would be pretty obvious to me. So for the first one, the only thing I asked for was the current through the 6K ohm resistor. Can everybody see this okay, though? I mean, are you able to view the screen? Class? All right, let me go through this with you. So for this one, you see we have 3 milliamps leaving, and these two are in parallel. That's the only place the current can come from. Therefore, the current I naught here would be equal to the total current minus 3 milliamps, which is leaving, times current division. So it would be the opposite resistance, which is 3K, divided by the sum total, which is 3 plus 6 or 9K, or minus 1 milliamp. Now, if there's 3 milliamps coming here, do you all agree that I would have 3 milliamps where I put that red arrow? Does everybody see that right here, class? This is actually based on a problem that you had for homework, 2 problems. So it was a very easy problem. What people did was try to solve this with nodal equations and all sorts of stuff. The only thing you need to do, and this is the whole gist of this course, is to realize what's asked and then get at it. And this is an open problem, so you could use anything you felt confident with. This is simple current division. There was nothing tricky about that. It took about literally 5 seconds if you just looked at it. Next problem was a simple nodal problem. And for this one, now, again, for nodal, you have to ground the lower part. I believe the circuit's right out of your book too. I'm not absolutely certain, but I think it is. So for this one, if you ground this, that's 0 volts. Now I'm going to solve for V1 here. Please listen to me now. Make sure you see this. I'm going to assign a current I1 this way, I2 this way, and I see I have 8 milliamps coming this way. Do you all see this, class? Can you? I got to make sure you can see. Very few screens on. So here I'm going to put I1 is equal to I2 plus 8 milliamps right here. Agreed? It's only one equation, one unknown for this. I just need V1. Then I have I1 would be equal to minus 12 minus V1 over 6,000 is equal to I2, and I2 would be V1 over 6,000 because these two are in series. V naught is something I'm going to get at after this. I mean, I could get at it directly, but it's easier to do it afterwards. So this current I2 would be V1 divided by 6K, this goes to ground, plus 8 milliamps. And at that point, I have one equation, one unknown. I simply multiply everything by 6,000. I come up with this equation. Then I combine V1, and I find for V1 minus 30 volts. Is everybody okay with that, class? Right? Now that voltage is what? It's across a series combination of these two resistors. So if I wanted the voltage across the 4K, I could get it a few ways. I could find I2, which is just V1 over 6K, and then multiply it by 4K. That's one way. Or I could simply say it's V1 times 4K over the sum of 4K plus 2K, or 6K, and that's voltage division, and that would be minus 20 volts, and that's correct. And that should take no more than a minute or two. It's honestly, it was a very straightforward problem based on the homework too. Then the last problem was meant to just take this first problem and do it with Thevenin. Now Thevenin is something we went over, and it's real important you know Thevenin. I'm telling you this, you're going to get it again and again and again. So for Thevenin, first thing I do is identify the load resistor, then remove it. So that would be removed. This resistance right here. Do you all agree with that, class? I mean, you got to be able to identify the load first and foremost, then remove it. So you would take out the 4K. Do you agree with that, everyone? I'm just looking for any kind of, just a thumbs up so I can see. Most people do not have their cameras on, and I don't blame you. But I'm
Yes,
just
we
trying
agree
to
with
make
you.
sure. All right, if you've got that, that's a point. All right, the next thing is R Thevenin. Now for R Thevenin, you take out the current sources, you remove them. They no longer are part of the circuit, and you short the voltage sources. So R Thevenin is just 2 plus 6, or it's going to be 8K. That's 2 points. Very quick. You can get this just by inspection. Next, you have to find the open circuit voltage. That's the voltage across where that 4K was taken out. You all agree with that?
Yes.
Here, I want to make sure everybody is clear. Now, if this 4K is gone, oh, come on. If it's gone, I hope I can draw. I can't even do it. Anyway, if it's gone, then how much current would flow there where I have I2, class?
0.
Yes, that's what I really make sure of, right? If this is an open circuit, no current can flow there. Do you agree?
Yes.
I try to make that perfectly clear on a few problems. All right, that means if I take a look at this, all the current, the 8 milliamps is flowing around this outside loop, correct? You all see it, it's flowing this way. You just show hands here, how many do? I mean, any kind of affirmation helps me see if you understand. This is not meant to be a difficult problem at any level. So that means the voltage across this 6K where I have the cursor would be 6K times 8 milliamps, or 48 volts, plus on the left, minus on the right. Do you agree with me?
Yes.
Right? Right? And so I even put it here. I mean, well, sorry. I didn't put it there. I drew the circuit. So if you take a look at this right here, then what we can see is if I want this voltage, remember that's plus to minus 48. I start at the negative terminal. I see I drop 12 volts right here, right? That would be the negative. I'm coming around. I would lose 12, minus 12. Then I would lose what? 48 or minus 60 volts. Do you agree, class? How many see V open circuit would be minus 60 because there's no voltage drop across that 2K because there's no current, right? How many see this now? I can see hands. I can see something. Please let me know if you do.
Yes.
Okay. It's meant to be easy. Remember that. So if that's the open circuit voltage minus 60, now I draw my circuit. I've got the Thevenin resistance. I got the voltage minus 60, and I put in my load resistance, and I find the voltage across it, which is just minus 60 times 4 over 12, because they're in series, or minus 20, which is identical to the first one. So that's your check. Do y'all follow me, class? This is about a 5 to 7 minute quiz typically, but a lot of people didn't. I think they were cramming, because when you cram, you get completely confused and don't know which way is up, from what I could tell. Now, there were excellent grades, just for the record. There were 10. There was at least 110. But what I'm trying to tell you is do not cram. Right? Do not cram, because a lot of people cram for this. I could tell just on some of the stuff I got in response. Now, the next problem, or I'm sorry, the next quiz, part B, was basically identical in nature. So here's part B of it. And I wanted to find Vx right here. And if you look at this, you got 1 milliamp going this way, 5 milliamps going this way. So that's 6 milliamps that has to be coming through that resistor where the 44 ohms is. Do you all agree with that, class? Show of hands here. It was meant, this is the very first part of the course. Some of the currents into it, some of the currents out of. If you understood that, then this was a piece of cake. Now, if you look at this, because current is entering here, where the negative sign would be the positive terminal, and where the positive terminal would be the negative of the actual voltage, sense positive. And it would just be 6 times 44, or 264, but it'd be minus. Are you with me, class? Just like the first part of the last, of quiz A. So that's 2 points there. Next, again, this is going to be a nodal analysis. And here, got to ground that, so that's 0 volts. I label I1, I2, and I3. Now, again, you can label these things any which way you want. You can have the currents going in either direction. You could use that as VA. It doesn't matter the designations, just the fact that you have to understand what they mean and be consistent. Do y'all follow me, class?
Yes.
Don't worry about your grade right now. Listen to what I'm saying and catch it. Please appreciate this. It's for your own good, not mine. All right, so if I look at I1, it's the voltage on the side it's entering, which is minus 12, minus V1 over 6K. That's I1. Do y'all follow me? That's I1. When I look at I2 here, it's going to be plus 24 minus V1 over 4K, right? Come on, this is not that difficult. This is fairly straightforward. And when we look at the current I3, it's going to be V1 over, coming out would be I3 on the other side would be V1 over 12K. Do you all agree with that, class? Now you just solve for V1. I don't care how you do it, but you just have to get all the knowns on one side, the unknowns on the other. So it's going to be 6V1 is 48 volts when all is said and done. Are you with me? And it doesn't matter how you do it. Anyway, when that's done, you get V1 is 8 volts. Okay? How many see this? I don't care how you do it, but you have to be able to do calculations accurately. The plus and minus signs on V1 here. Somebody asked the question. V1 is measured with respect to ground. Now, when I measure the current I1, I take the voltage with respect to ground on the side the current is entering, called the positive side, which would be minus 12, minus the voltage on the side where the current's leaving, the negative side, which is minus V1 over 6K. This is just the standard way we do it. We've done it on at least 2 or 3 lectures, class. Somebody asked a question about this. So it comes down to V1 is 8 volts. And here I'm using voltage division again. You don't have to. If you want to write some equation, go ahead and do it. But to me, it's simple voltage division. V1 here times 4K, right? Divided by 12K would be V9, or 2.667 volts. If you wanted to take V1 divided by 12K and get the current, then multiply by 4K. It's completely acceptable. And it doesn't matter what your symbols are. So please, if you don't need to write me and say, but I used VA, not V1 or something like that, or I had the currents in the opposite directions. Nevertheless, if you were consistent, you would get the same exact answer for V naught. That's my point. And that's what we're looking at with these simple currents, simple circuits like this. And then the final thing is to take use Thevenin's analysis technique on this. So the very first thing you have to do is identify the load resistor, or the thing you're going to remove. And this is worth 1 point. So it's got to be 4K here, correct, class? Now, I'm going to go over this again. Y'all agree with that? You got to remove it. So you take the 4K out, right? Right? It's removed from the circuit. No current can flow through the 8K where I have I3. Now, when that's removed, the next thing you're going to do is get the Thevenin equivalent resistance. You don't have to do it in this order. Right? You just don't, but I'm just saying I'm going to, okay? All right, what would the Thevenin resistance be? For sure you have 8K, right? Now, when these are turned off, they become short, so both the other side of the 6K and 4K go to ground, or they would be in parallel. Do you agree with me, class? That's 2.4K, right? Right? 6 times 4 is 24, 6 plus 4 is 10, 2.4 K ohms, plus 8K, which would be 10.4 K, right? So that's our Thevenin. Do y'all agree with that? Everyone? Okay, next, you have to find the open circuit voltage. For this one, remember, this is removed, that 4K, so there's no current flowing through 6K. So to get the open circuit voltage, I'm going to go from the negative and work to the positive terminal, knowing there's no voltage drop across that 8K. Here's how I did it. You can do it several ways. If you look at this circuit right here, I've redrawn it down here, and I've taken out the actual 4K resistor. Do y'all see this down here in this corner? Can you see it? Everybody, just let me know if you can see it so I know. All right, if you take a look at that, if I want this voltage between the negative and positive, there's a bunch of ways I can do it. Probably the easiest this. If I start here, you see I have plus 12, plus 24. That's the voltage. If I combine these two voltage sources, are plus 36. Do you agree with me? I'm just talking my way through it. You could do it other ways. Do you agree with that, class? All right, I got 36 volts pushing current this way. And then I have 10K opposing it, correct, class? So if I have 36 divided by 10K, that's 3.6 milliamps of current would be flowing around here in the outer loop, right? Now, again, this is the way I chose it. If I take a look at that, that would give rise to a voltage of what? Well, it would be 3.6 milliamps times 4K across here, and it would be such that it would be minus there, right? Oh, sorry. It would be minus there, and it would be plus on this side. It would be 3.6 times 4K, right? And I believe that's 14, isn't it, class? 14.4 volts. And that means if I start here, just look, I start the negative terminal, I got an increase of 24, shown right here, and then a decrease of 14.4 is 9.6. If I go this way, remember, I'd get a decrease of 12, and then I'd get an increase. Now I'd have what? Plus to minus. It would be plus on this side, all right? Because current's flowing that way, so it'd be, I don't know if I can do this. It would be plus right there. And, oops. I'm trying to show you it's plus there. It's not going to let me. Don't worry about that. Anyway, it's plus on the right, negative on the left. So it's minus 12 plus 21.6 is 9.6. Then the voltage across the 6K is just 3.6 times 6K. And no matter how you get it, you're going to get 9.6 volts right here for the open circuit voltage. Do y'all follow me? If you want to use a different tact, have at it. I'm just doing it my way. Then you assemble the Thevenin equivalent, I'm sorry, the Thevenin equivalent circuit. I put the series R Thevenin with the series voltage of 9.6. I put the load on there and I find the voltage across the load. So it was 9.6 times 4 over 4.4, or 2.667 volts, which checks this one. So you checked your answers. The quiz was meant to be very quick, very easy to do. And I'm just going to encourage you people to make sure you stay up to the homework when it's assigned, you do it. And then after, the other piece of advice I have is try not to use the book to look for similar problems. Don't do that. You're wasting time. The problems are developed specifically to see if you understand the material, not if you understand how to compare that to something in the book. All right. Now, with that said, I'm going to tell you one other thing. There were a bunch of people that didn't take it, and they got a 0 if they didn't have an excuse. That was added in or factored in, I assume. Some people did get a 0, even though they took it. They just put their name on the paper. I'm going to tell you this. First, if you struggled with this, had a hard time, reevaluate how much time you're spending on it, and then, you know, make the adjustments. Cramming for this course will get you absolutely pulverized in the end. It's a cumulative final, and this is a fairly easy portion of the course. I'm trying to just give you a level of concern. I don't want to scare you. It's the people that have been keeping up probably did pretty well. But because of the exceptionally low average, it was like 2.5 for both courses, roughly, it's a slight difference of about 1/10 of a point or so. What I'm going to do this time and this time only, I'm putting a full 3 points added to your raw score. All right. Now, there are people that get 13 out of 10, so they got 130%. But what I'm trying to do is give you enough incentive so you just don't want, I mean, you'll at least have something dangling before you. You can do this course, but please treat this as you would thermodynamics with Birch. Don't treat this as something that's a cakewalk. It's not. It requires your time, about 2 to 3 hours between lectures. And I'm trying to be as honest as I can. Do not mess around with this course because you'll get eaten alive. This is very easy, what I've shown you. This should have been a very high average. All right. And again, they're designed specifically to make sure you understand the material. Okay. Now, any questions?
I was kind of confused on problem 3 on quiz B on how you got 10.4 k ohms.
All right, let's go through that. All right, who's asking this?
That's me.
All right. Now just watch here. You see a circuit, right? Right here?
Yes.
Okay. If you take this resistor out, if you want me to, I'll redraw it right now. But if you take it out, you see it doesn't exist there, right? It's just V naught, right?
Right.
All right, now what do you do with the sources? You short the currents, I mean the voltage sources, and open the current sources, right?
Yes.
If you shorted this and this, do you see how effectively the 4 and 6K would both be at ground potential on one side and both be at V1 on the other side?
Yes.
Therefore, they're in parallel, right?
Yep.
All right, so those two, the parallel combination of those could be gotten from taking multiply those together and then divide by the sum. So you could take 6 times 4 or 24 divided by 6 plus 4, 10, or 2.4K. That's one way to do it. Or you could take just 1 over 4K plus 1 over 6K and do it that way. Either way you do it, it comes out the same. It's 2.4 k ohms, okay? You follow me on that or not?
Yes, I follow.
All right, so that's just added to 8. So therefore, it would be 10.4K, right?
Yep.
All right, now if you have that, 10.4K, you understand the 4K is the load, right?
Yes, I do.
Now you've got to get the open circuit voltage, right?
Yeah.
And the key is when the load, and I drew it here, is removed, no current flows through this 8K ohm resistor, right?
Yeah.
The only thing I have to do is find the current going around a simple circuit. You see I can combine these two, and that would be 10K, and I combine these two, that would be 36 volts. Therefore, 36 by 10K would be 3.6 milliamps. Do you see that, John?
Yes, I do.
And now you can get the voltages on each of these, right?
Yes.
And then you can go from the negative, either way. You can go this way, or you can go this way, noting that there is no voltage drop across that 8K because there's no current through it. Does that answer any question you have?
Yes, that makes sense.
And if you have others, please let me know. Now, I tell you, I asked the grader about this, and he's probably on here, even though I don't see him. He probably is, or yeah, I'm sure he is. Anyway, the thing I want to tell you, from what I could gather from what he said, and he graded a lot of these, people started this and they're writing all sorts of nodal equations and stuff like this. They didn't even look at the problem. This is a simple problem. It doesn't require any of that. And this is the type of stuff you're going to get over and over again. You have to be able to appreciate what's asked for and get it. Don't do everything you don't need to do. Got it? Don't waste time. Get to the point. The next problem here, well, I mean, I told you to use nodal. That means you put unknown voltages. You just need one unknown voltage there. You could put another one if you want, but you don't need it. It's redundant. And this problem here on for the Thevenin problem right here, this was literally a book problem. Admittedly, it wasn't 8 milliamps. I forgot what it was in the book, and these resistors are slightly different, but it was the same problem in the book. And to do this with Thevenin, it's straightforward, especially if you got a current source. Now, for the second problem here, again, you got to be able to recognize what's asked for. Don't write a bunch of nodal equations off the bat. I didn't ask for Vy, just asked for Vx. So for this one, since you've got the currents leaving a node, that's what comes in. You've got Vx without ever writing any difficult equation. It's one equation. It's 6 times 44 with a negative sign. That's it. And the same with this problem here is just one equation, one unknown, solve for V, and then do voltage division. And if you want to solve for the current, the secondary current, then multiply it by R. That's fine. However you want to do it. And for the third part, the Thevenin, this one, the only thing, you weren't given the current flowing, so you had to calculate it. But these were straightforward, very, very simple problems, and they were meant to be simple, but they would get at the essence. If you understood it, it was clear. If you didn't, it was pretty clear too. And don't cram. If you want to take one thing with you, do not cram, get your sleep, and try not to waste time comparing the things and try to get some, illegitimate edge on this stuff. You're going to get hammered.
Professor, can you go over quiz B, problem 1 again? Just that solution?
Yeah, sure. This part right here?
Yes.
Evan?
Yes.
Well,
I had
look,
quiz A, but I want to see how you did.
That's fine, but just look at it for 1 second. What am I asking for? Vx. Look where Vx is, right? You see it? All right. Well, how much current's going through that resistor? 1 milliamp's going this way. 5 milliamps is going this way. How much is coming up?
6 milliamps.
6 milliamps, right? Times 44, or I'm sorry, 6 amps, pardon me, times 44 ohms, right? That's the voltage drop, right?
Yes.
So it's 264 volts, but what? The bottom part here, sorry, it's jumping like that. The bottom part here is labeled positive and the top part negative because current enters the positive, leaves the negative, correct?
With the bottom's labeled negative, the top's labeled positive.
Because current enters the positive terminal as you sense voltage and leaves the negative, right?
Yes.
That's it.
So it's negative because the signs are negative, positive.
Yeah,
okay.
I said, this is like putting a meter on there, and I said I put the positive side of the meter on the top, the negative on the bottom. What would you read? You would read a negative voltage.
Okay, thank you.
Now, please understand, this is supposed to get at the fact that if you understand it, you'll blow through these quizzes, and if you don't, you'll probably spend all day and get nowhere. And don't spend a whole bunch of time comparing on stuff. They're designed to make sure you'll just waste time. You have to do these things with your own understanding. And I don't know overall what the breakdown was or how many people are without any adjustment between like 8 and 10, between 6 and 8 and so forth. I didn't do that. But I did want to tell you, there are a lot of zeros, and that bothered me. Either they didn't take it or they put their name on it and didn't do anything. So I'm just trying to encourage you to stay up with this, okay?
Will the in-person quiz on Friday be covering the same material?
All right, well, this is a fundamental question. It's a good question. You're responsible for every single thing you learn sequentially. So everything you've covered before, you have to know for the next upcoming quiz and any other exam. It's cumulative. Now, will you be asked a specific question just about nodal? Maybe not, but you have to know it. You follow me? It's just...
So I have a follow-up question. So if we haven't had class since the last quiz, because I'm going to cover new material in a second, if that's what you're getting. Okay.
And that's exactly where I'm going. Okay. But everybody's wondering, well, what would be on it? Well, you're going to find out right now. Because I didn't ask certain things that we did cover, but now you're going to find out. I just encourage everybody, if for whatever reason you had trouble, just recommit yourself and please do not cram. God help you if you do. Some people can, I guess. And also, if you're contacted by anybody from the university, I think Nick Wared and Fred Cam, and there might be a few others, you must respond to them because they send me a response that they haven't heard from these persons. And if they don't hear from them, I'm going to assume you've dropped. Now, I'm saying this because I got some notifications from people, and I'm just following up. All right, back to this. Take it seriously. Now I got to get this camera if it works. All right, here's what I want to go through today. And this is something that I really don't want to draw on his book right now, the book you've got. I want to do this my way because it'll make it easier. This is called mesh analysis, and we're going to do mesh, and then we're going to do some stuff with time varying if we have time. Now, mesh or loop analysis, and I know it's out of focus. Give me 1 second. Okay, mesh or loop analysis. You see some problems that refer to it. So here's what it is in a nutshell. Please be attentive here. In this book that you have, it's mentioned, but it's not covered in depth. It's the sum of the voltages around any closed loop is 0. But here we assign these mesh currents. So let me go through it with you first. If you had a voltage source, a simple voltage source, V1, and I had a simple R here, R1, and I had a simple R2. As such, that would be a single loop, all right? Now, I know a current's gonna flow. I can assign that direction in either clockwise or counterclockwise, and regardless how I assign the direction, I will calculate that value. If it's negative, it means positive currents going in the other direction. Does everybody follow me on that? All right, now I'm just gonna put this as I1. And now I'm going to write an equation on the sum of the voltages equals 0. So there's a plus minus here, plus minus here. Now, do you all see that the voltage across this R1 based on the direction of current here would just be I1 R1? Do you all agree with that? I'm making it as simple as possible. And if you can give me a thumbs up in there, I know this may be aggravating. You might be angry about the quiz, angry about me, whatever. But it helps me, and it may help you too in the long run. Just let me know if you understand. What's the voltage across R2 is shown? And it's as easy as it seems.
I1
R2.
It's just going to be this time, it's I1 R2. Now, if you go ahead, and I'm going to sum from the lower left-hand corner right here around the loop, the sum of the voltages always equals 0. So if I start here, you see I get an increase of V1. Do you agree with that?
Yes.
Then you get a decrease of minus I1 R1.
Mm-hmm.
And then you get a decrease of minus I1 R2. And the entirety of that is 0. Do you all agree with that, class? Any way of any affirmation of all is welcome. Any affirmation is
Yes.
welcome. Okay, good. Now, I did this. It's extremely simple, and this is called a mesh current. You'll notice how it was localized here. There's nothing else in the circuit, so there can only be one current. And at this point, if V1 is given, you can solve in R1 and R2, you can solve for I1. And I'm not going to dwell on this. How many agree you could solve for I1 simply? And by the way, if at this point you can't see, you can solve for I1 simply, you may consider dropping this course, because at this point, we're well beyond that point. Everybody? Okay. Now, the next part. Now I'm going to add a bit of complexity. Please be very attentive here. I'm going to redraw that same circuit. I'm going to put R1 here. I'm going to put R2 here. I'm going to do something different. Then I'm going to put R3 here. And then I'm going to put another voltage here, plus the minus V2. Y'all see what I've done? I've added this portion right here, correct?
Yes.
Now that's called another mesh. And here are the sub-meshes. If you ever look online, there's a current flowing here that I'm going to label as I1. Only in this, I1 would flow through V1 and R1. But we're going to talk about what flows through R2. Then in this sub-mesh, I'm going to label a current I2. Now, please take a look at this. Don't worry about grounds in this one. You can put them in, but they do nothing. Y'all with me on this?
Mm-hmm.
Now, please listen. When I go around, can you see that this voltage, let me use a different color code. This voltage right here would be plus to minus R1, I1, right? As I've drawn it. Do you agree with me?
Mm-hmm.
Now listen very carefully. When I look at this voltage, you take the net current entering the positive terminal. Now look, you see how I1 is assumed into it, right?
Mm-hmm.
But I2 is going out of it, right? Y'all follow me? Because this is called a submesh. Right here is where the two intersect, where you have current going down from this one, but coming up from this one. Do you all see that?
Yes.
Everybody? So the voltage here would be this voltage. I'm going to just call it V2. V2 there would be equal to the quantity I1 minus I2 times R2. Do you all follow me on that, class?
Yes.
I want to make sure y'all do. I mean, if you do, please, I see
Yes.
three people. All right. The more affirmation I get, the better I feel about this course. Because if you don't see,
Okay. So it's minus because they would be going in opposite directions when they hit that resistor.
yeah, and who was asking that?
Amanda.
All right, Amanda, do you see how, think of like water swirling. This is swirling here, this is swirling here. What's the net amount coming down? Well, I've got I1 coming down this way, but I got I2 going up, right? So it would be reducing that amount. Do you agree with me?
Yes.
So you'd subtract I2. I1 minus I2 times R2 would be the voltage there, V2, as drawn. Follow me? Everyone, class? Hold on for 1 second. All right, somebody asked, is this arbitrary? Yes, but here's a suggestion from me. Now, I've done this probably for 40 years of my life or more. I've got a technical degree in electronics. I've got a bachelor's, PhD in electrical engineering. Here's what I've always done is develop a system of consistency. For you mechanical engineers, it'll help you too, and probably aero and industrial as well. I always, if given a choice, take the currents flowing clockwise. I just do in all the submeshes. It kind of rings true in my mind. That's the way I do it. Now, you don't have to do it that way. Whoever asked that, yes, I could put I2 the other direction. I could, so they'd sum. But I always do it I always do it clockwise. You all understand that? It's just me. It's a consistent way. I've done this for 40 years of my life. And you'll find out somebody at some point should give you a lecture on tricks that help them. And one of the things, they have all sorts of subtleties. I circle my minus signs because I obviously, as you get older, your eyes aren't as sharp. And when it comes to money and consulting, you can lose a lot of money quickly if you don't get the equations right. So I circle minus signs. I always have consistent patterns. And this is the way I do it. You can do it any way you want, but I suggest you develop a consistent pattern. Now, when I do it this way, there's two meshes here and there's two unknowns, I1 and I2. Do y'all follow me on this?
Yes.
Now, when we go around any closed loop, we will sum the voltages to 0. The last time I went around this closed loop, right? Right, class?
Mhm.
Here I've added this complexity. It's still going around this closed loop, and I'm going to write it right here. Hopefully you can appreciate this and see it. So when I go around the first loop here, I would get an increase of V1. Then I get a decrease of R1 times I1, just as before. Do you agree with me?
Yes.
All right, and then you would get a decrease of what? I'll put the R's first. R2 times I1 minus I2, correct? I've gone all the way around now, haven't I? Class?
Yes.
Right? I went here, started, that's an increase, decrease, decrease, right? And this whole thing sums to 0. Do you agree with me? I'm going to break it out and show you. Y'all agree? Now, you have to organize them so you can put it in terms of a matrix. Here's where your TIs, your 89s, your 84s, your 83s, your Inspirons, and God knows what else you have on the shelf. All those things are going to be worth their money. So now what I'm going to do is organize this. First, I take the knowns and I put them on the other side. So you see that's minus V1. Do you agree with me? Now I take the I1 coefficient, or I1 unknown, I put it here, and I find out what values I have. Well, I have R1 and R2, but there's a minus sign. I'll put the minus sign out in front. I have R1 plus R2, correct? This is just reorganizing the first equation. Do y'all see it, class? Anything that can help. All right, now, the second equation, I got a minus R2 times a minus I2. That's really what? Plus I2, right? R2, right? And this is just Baginski's method. You don't have to do this. But if I see two minuses and one plus, I multiply both sides by a minus. Make that plus, scratch that, put a minus sign, and I circle mine. Follow me? That's your first unknown equation. Okay? Now your second unknown, just listen to me now. Now this is the way I do it. You don't have to do it this way. I ignore this polarization on V2 here. I'm going to say I want the voltage plus to minus this way. Call it V2, right? Because now I'm in this subloop. You'll appreciate this in 1 second. You with me?
Mm.
Now I'm going to go around this way. I'm going to start. I always start in the lower left-hand corner. You don't have to. I'm consistent. I do. I can see this is a voltage drop, right? So here's my second equation. I'm going to have minus R2, right? Now I'm going to have what? The net current going up. What's the net current flowing up? It's into the positive there. Class?
I2 minus I1.
Yes. It's now reversed, I2 minus I1, because I've got the polarities reversed, because I want to take all these as drops around that closed loop. Y'all see what I'm doing here? I'm allowing the submesh current to dictate the polarity on these resistors. That's positive, that's positive. The secondary currents would be subtracted from that. And I know that because I'm always consistent. Follow me? They don't have to be, but I'm saying I'm going to try to do it that way so I'm consistent. Are you with me on this, class?
Wait, one question. Why you said that you got the polarities reversed? Why you have a negative on top and the
Because I want these as drops. I'm saying I2 is going to be entering the positive terminal. So if,
Okay.
see how I label this plus the minus?
Okay. Okay.
Then it would be I2 minus I1 would be the net current flowing up, right?
Mm.
And that's times R2 is the voltage. Then you would have minus R3, right? Times I2, right? And then minus V2, correct?
Mhm.
Equals 0. You all see that? Yay? And if you want to ask a question, if you don't mind muting your mic, go ahead. If it gets out of control, I'll let you know. Now, this is up to you, but this is just me. I take, at this point, all the knowns, put them off to the right. So I move this, and I'm going to do it right here. I'm going to add plus V2 to both sides. So now I get V2, right? Right? Everybody? And then what I'm going to do, I see that. Now I'm going to organize this. First, you need I1 first. So for I1, I've got R2. Take I1 first, then I have R2. Do you see how I got a minus times a minus is a plus? So it's that, right? And then I have minus what? I2, right? And it's going to be R2, right? Plus R3 is equal to V2. How many see that right there? And that would be your second equation. Let me move it up for you. I'm sorry. I got that. You with me?
Yes.
Now you put them in terms of a matrix, and I can do this fairly quickly. This is a bit abstract. So I have R1, R2.
Do you mind moving the paper a little bit?
Yep, I get it. R1, R2 right there. And I have to read from above, right? R1, R2 right here. Then I have minus R2, right? Right there. Then you put a column vector sign, then I1, I2. Then down here, now the coefficient is R2, right? And the coefficient here is going to be minus R2 plus R3. And this is a column vector. The first one is V1, and the second one V2. You all agree with that, class? Right?
Mm-hmm.
All right, now you see, this is completely in terms of unknown R's, right? I didn't assign V's. Normally the voltages would be known and the resistances you would solve for I. Are you with me, class?
Yes.
All right, now, having done that.
Okay, wait, could you go over again? What do you know and what do you not know? Which are given?
The voltages V1 and V2 would be given and the resistances would be given. We would be solving for the currents. Before we solved for the voltages, didn't we? Here with mesh analysis or loop analysis, you solve for currents.
Or on the matrix, why is it positive R2 on the bottom left? Would it be negative?
Well, let's take a look at the equation.
Oh, wait. Yes.
Huh? Minus,
yeah,
minus would be positive, wouldn't it? Minus R2 times minus I1 would be positive, wouldn't it?
Yes. I thought, so in the bottom left, is that R2 from I2 in the first equation?
I1, right? This is the equation, right? Take a look. That's this, right?
Oh, yes. Okay. I see. I misread the matrix. My bad.
I mean, but if you go through this, I know I've got everything in terms of abstract values, but you follow me on this, class? And this is what it amounts to. No, whoever asked that, Riley, about the V2, I changed the polarity in the second mesh because I want I2 to dictate the positive terminal. Whoever asked that, Riley, something, okay? I don't even see your name. You're probably on the next page. And I have no idea how many pages we have. Oh, we got a lot. We got 4 pages. So I'm sorry I can't see all of you. I barely can see anybody on the first page, but that's okay. I want to make sure you got this. Got it? Now, something I'm going to say here. Thevenin, nodal will solve the same problems as mesh. Y'all with me? It's a technique. It's just one of many, but it helps to be appreciative of this, especially the MEs and arrows, because you do fluid flow. And that has a direct analog to fluid flow and things. I think you know about, I got to be careful. Let's see, there's, I don't know if you know about eddy currents, laminar flow, and all the different things. And when you have higher level courses, in fluid dynamics, you're going to find out this is actually something that I believe parallels some of that. Okay, class? Now, I've got about 3 minutes. This is not major rocket science what I'm talking about. I didn't get to my capacitor thing yet, and I'm not going to today, but next time I will. So what I'm going to tell you is I have given you a whole bunch of problems out of chapter 2. And some of those, they said, solve with mesh analysis. Now, I'm pulling it up just for you so you can see it. For instance, you see how in problem 257, they say, find I1 and I2, or find V0, and I'm going to say I1 and I2 using mesh analysis. Now, you have those problems, right? Do the problem without looking at the solutions. Just solve it. Don't be lazy. Find the matrix, do the whole 9 yards, and see if you get the same answer. Do the same thing for this one, 258. Now, does anything bother you about 258? And I want to say something here on purpose for this problem. This is 258. Take a look. Now, I know people, I got a very exacting email from somebody saying, you need to stop on time. We have things to do. I will stop on time, but realize I have an office hour afterwards. I can't get everybody in there all the time, so I'm going to continue, but you may go. All right. And on the quiz, I will start it at the bottom of the hour, and you will get exactly 20 minutes, and I'm going to shut it down for everybody because somebody complained that people had more time than they did. So I'll give you all exactly the same amount of time and no credit for any late work. All right. I got this from one person. I want to make sure I'm fair to everybody. I try to give more time, but since that person complained, I'm going to make sure I'll give you exactly the same amount of time. No more, no less for everybody. All right. Then it will be within the class time. Got me on that? I'm trying to be fair.
Does that include students with accommodations?
Nope. You get more time, period. Okay. Anybody who has an accommodation request will always be accommodated unless you're done beforehand. By the way, I think some of those people that finished early, I got to be careful about it. I believe at least one was one. And I'm going to just stop there. I don't know exactly what they got, but so maybe you don't need all the time, but you will have it. I'm going to make one remark about this. Usually your first answer is correct from what I've been told by people in psychology. That's when you second guess yourself, you get into trouble. Just remember what I'm telling you. I don't know if anybody's heard that before, but I'm trying to help you. Test taking is not supposed to be about gambling. It's supposed to be about knowing. Have confidence in yourself. Your first answer is right and relax. You can check it, but sometimes it's not a good idea. Anyway, for this one, I want you to take a careful look at this. Is there anything that we know? Take a good look, class. This is like a typical thing. If this was thrown at you on a quiz, what's the one thing you might pull out of there before anything? Anyone?
I2 is 4 milliamps.
Exactly. Now you've got I2, right? And therefore, it's only 2 unknowns, correct, class?
Mm-hmm.
It reduces the complexity immensely. I don't have to go around this loop. I can't go around this loop, can I? Because there's a current source, and I can't sum voltages through a current source. You see what I'm saying? It's got to be through a voltage source or through resistors. I can't sum them this way. Okay, very good, whoever said that. Let's go down one more. These are all going to be homework problems. Now I'm in my office hours, so you may go. You do not need to stay, but I'm trying to be fair about this to everybody. If you need time with me other than immediately after class, send me a message. I'll try to accommodate you, or my grader will. I can't, this is 100 people in here, and it's hard enough just managing the amount of email I get from this course regarding simple things. Now, if you've got to go, go, and please be safe. Stay out of areas that you don't need to go that are high traffic, because I haven't even seen today's update on COVID. All right, now this one particularly, what do you know, class? Second, 59.
I think I5 is also 4 milliamps. I don't know. Is it I1? I can't see properly, but something's 4 milliamps.
Can you all see that? It's 259. Can you all see that or not? People?
A little bit. Yeah, the eyes are kind of blurry, but I think it's I1 that is 4 milliamps.
That is, can you all see I1, guys? I think it's the size of your screen. Are you on a phone or something?
No, I'm in a computer and it's full time, but it's fine. Yeah.
I mean, on phones, I can't see the stuff either. On laptops.
I'm on a 25-inch monitor and I still can't make out the subscript for the eyes.
Yeah, it's really hard to make the subscripts for the eyes, but you can see the rest.
Really?
Yeah, that's better.
I think that's
Yeah,
glare though. That's
that's
glare.
much better. Oh.
Better?
Mm-hmm.
Thank you. I didn't know that. All right. I1 is 4 milliamps. You agree with me?
Mm-hmm.
Now, you still have two loops, don't you?
Yes.
Still have to write an equation for some of the voltages around there equals zero, some of the voltages around there equals zero, right?
Yes.
All right. Now, listen. Based on I2 and I3, what is V naught? Someone tell me. It should be plus to minus, right?
Mm-hmm.
What is V naught?
1K ohms times I2 minus I3.
Exactly. And please make sure positive current enters the positive terminal. This one, I3 is flowing out. It would be subtracted from I2. Got it, class?
Yes.
Very important you do that. All right, I'm going to give you that problem too. For this problem, last questions about. Can everybody see this one?
Mm-hmm.
Y'all see this or not?
Yeah.
Guys, help me out.
Yeah.
Yeah, we
Yeah.
can see.
If you can see this one, tell me one of the things that are obvious. Just step back and look.
Okay. You have I1 is 4 million.
No, somebody else. I've been in this too long.
Uh,
Somebody else.
I4 is 2 milliamps.
I4 is negative 2 million.
Wait. I4 is minus 2, right? Take a look at the direction. See? Joes? Be
Yeah, I
sure.
see it now.
Now, if you answer, don't say anything. So that's it for you. All right. Evans, you can play, and so can Amanda if you want. But I'm trying to get everybody in here. What else?
I1 4 milliamps.
Go ahead, say it. Either one.
I think we both said that I1 is 4.
Yes, 4 milliamps. Milli. Don't forget the units, people, okay? A positive 4. All right. Both of you two now, quiet. Just help me on this one. I want to go over here. And before I leave today, just talking through them helps, believe me. Not you guys, somebody else. And you don't have to have your screen on, but just help me out here. What can you
I1
tell
is
me?
2 milliamps.
Who's talking?
That's John. That's me.
Oh, Java. All right. Yes, important to see that, right? You've got that. Now look, you just have one loop, don't you?
Yeah.
Yep.
All right. How many feel that at least they believe they can take a shot at these and probably get them right? I believe you can. If you are willing to try, and I mean, then you should absolutely destroy this. But I'm going to make one other suggestion. Please do not take a look at one or two of them and say, oh, I got this, and move on. I'm going to tell you, it's false confidence. You're going to get hurt. Please do these problems. All right, I'll send out more information about the quiz tomorrow. You got me on that? I've got to check with people, got to make sure I'm cleared up there, that there's no COVID terror that's going on up there. Matter of fact, right now I have to go through and read the COVID stuff. Now listen, if you had a bum time of this for whatever reason, don't kick yourself, it'll do no good. Just turn the page and then from it, figure out how you need to study different, what you need to do, whatever it takes. But listen, this is not a class for superstars. It's just a class for people that will spend time. If you spend time in this course and you've got modest academic abilities, you do very well. If you blow it off and cram, you'll probably flunk. And that's all I can say. Think of it as thermo. Now, I didn't take Birch for thermo or anything like that, but I understand thermo is a thing that builds consistently on every past thing. So you got to know it all. It's the same way here. It's not like history of Europe and then the history of Asia. It's not separate. Okay, any questions at all?
Since a lot of times the questions on the quiz are going to be a little bit harder, is there any way for us to practice?
Now listen.
Harder
I
questions?
want to just tell you this. I use that word and it's not fair word. Any problem I give you out of the book, if you haven't seen it, you'll say it's hard. I promise you this. If you don't see it beforehand and I throw one at you, oh, that's hard. I've done it. Those problems I showed you, went over them. You see these things again, oh, they're easy. It's all with respect to what I guess your level of understanding is. Those problems were trivial. There were no 2x2 matrices to solve. None of that. They were easy. All right. The problem was people weren't looking for what they were asked. They try to, like, I would say knee-jerk solve for everything when you aren't asked to do that. Solve for what's asked for. That's the real moral of this story.
Well, sorry, I know that for me, like, because we talked about like this quiz would be harder than the one that we would have had.
Yes, it is.
I overthought for sure on number one. Like, I was like, I thought I knew what it was, and I was like, there's no way it's that easy. And so then I overthought about it.
Me too.
Well, I'm going to level with you. If I ask for something, it's what I want. And the only reason I say that too is, look, to me, the first quiz that I gave, there was nothing where you had to even write one mesh equation. I mean, one nodal equation. If you look at that, it's a no-brainer, right? There was nothing that required an equation of this equals that. It was just by inspection, you could get every answer, right?
Yeah, I did the same thing for question one. I think I just overthought it, and I went to writing the nodal analysis and finding V1. And then I realized, I was like, I don't really need all of this. But at the end, I've already written all of that.
Well, for the record, that extra 3 points is going to take care of that because there's only a 2-point problem. But I'm telling you, this is much easier than what I usually give on the first quiz on the pass. I think about it. Now, I say that yes and no. Usually you get 2x2 matrices. This time I didn't. It was very easy.
Can we use a pencil on the next quiz if we're just more comfortable with that?
Here's the problem. You have to make real sure the answers. See, your work's got to be visible. Pencils, when you take pictures of. I've had this happen to me in the summer and in the spring. I can't tell what they wrote. I mean, unless you're using a dark lead and it's clearly visible, please consider the grader on this one. He has to grade this.
Yeah, I just had to like restart on whole new pages multiple times because I realized I was like doing it differently because I had to write in pen.
If you want to use a pencil font, could you put the answers in the boxes in pen and circle it?
Yeah.
Sure.
And because it's very difficult when you take pictures to grade that stuff if it's in pencil. And I'm just leveling with you. I've had people write in pencil. And then I try to look at what they're doing. It says, there, it's gone, there, it's gone. So if you're sure after you take a picture it's there, I'm fine. But I mean, it's got to be there and it's got to be absolutely visible. It's got to be as if it was pen. And then make sure, please put the answers in pen. Okay.
Okay, thank you.
But because the second quiz is going to be in person, are we going to give like a paper?
Yes, I'm going to pass out real paper.
Yeah, so then maybe we can just do in pencil.
All right. Yeah. Okay. I'm not going to fight that fight. Sorry.
I have a question kind of about like a general of the class. So sometimes when I do homeworks, I like to look up the solution, not because I cheat or anything that wouldn't help, but I like kind of seeing broken down solutions, especially after I get stuck.
Yeah, here's one suggestion. Take a shot at it without looking at anything.
Oh, yes. I've been doing this.
And then look at it.
Yeah. I've been doing this. One thing is that sometimes, at least with some of these homeworks, I would have trouble understanding where you got the solution. I was stuck. And I look at your solutions and either they're solved in a way we haven't learned yet or something. I was just wondering what the name of the book that you are assigning the homeworks from is called.
Well, it's going to change in a second, but this one is Dave Irwin's book, and it's on circuits. But I'm going to be using books by Hayton Kimberly, books by, oh God. Oh,
that's you have to tell me now. I'm just wondering because sometimes like I'm going
to use this book very shortly. Yeah. I'm going to be using this book for some, but see, in the other courses, they're going to cover rotating machinery. I don't usually cover that. They're covering all sorts of stuff where they're going to be doing, I'm going to do 3-phase power, but rotating machinery is one of the favorites of the guy who wrote this. And they're going to do some things with microelectronics. Now, 3-phase synchronous motors or something, I just changed out a capacitor and actually changed a motor in an air conditioning system. I learned a whole lot about those, but I don't generally cover this. Now, the other class will. And if you're interested in rotating machinery, you might consider at least sitting in on there, if not changing to that section, those sections.
Yeah. Is there any chance that you could, when you assign a new like photo of homework, you just say like what book it is in like the addition at the bottom.
Yeah, but one other thing too, some of these come from note sets. I've got note sets that go back to when I was in college.
I mean, if
Of
it's not possible, that's fine. I was just wondering because sometimes I like getting like multiple directions of solutions because it kind of helps me visualize how to do it.
Sure, but
after I've
tell
done
you
it.
one thing I do. The solutions manual for this book I put up there. So any book I use, if I have it, I put the solutions manual.
Yes.
The answers from the solutions manual. Just so you know that.
Yeah, thank you. I was just having trouble sometimes understanding some of the solutions that were posted.
Yeah, and by the way, he goes through Fourier analysis. We're not going to need that. I don't need to do that with you guys. I do it if this is a regular electrical course, I will. Yeah, he's already jumping. This book jumps right into some complicated stuff. I prefer to do it this way.
Really quickly, sorry, but did you say earlier that the grades for the quiz one are supposed to be in already?
Your quiz, if you look on Canvas, should be graded and up there. Y'all see it?
I don't think it's listed yet.
It's not up.
Grade is not assigned yet.
Hold on. Is my grader here? There was supposed to be, if you look on Canvas, you don't have a quiz that you can download?
No.
Nope.
The grade's not there.
Yeah, it says it's still being graded. Like there's no grade yet for it.
Let me remedy that as soon as I'm done here with my grader. He's not on, is he? I don't see him. Hold on. No-brainers are different for people with zero background circuits. It's true. I'm glad you didn't say no brains. Anyway, whoever said that, I'm going to tell you, yeah, that's true. If you're not familiar with what a resistor is, then it's hard. But hopefully over time, this thing will be very apparent to everybody. If you've been doing them, it should be fairly apparent what I'm telling you. All right, I'm going to make sure the grades get, everything's back in there right after this. I thought he put him there, but maybe he had a problem. And I'll get him to you as soon as I'm done here. I apologize. All right.
Dr. Baginski, will the 3 additional points already be added on there once they go in?
No.
Okay.
No. Okay.
Dr. Baginski. So just to clarify, on this upcoming quiz, the things that we learned that weren't on the last one are supernodes and the mesh analysis.
Well, you didn't get any 2x2 matrices either, if you want to be truthful.
Well, yes, I'm talking like.
Yeah, it's everything that we've covered is fair game.
Is it just
and that thing with like a source in series and a
source
current
transforms
source
is
in
fair game. I mean, but you would use those if you were given a wide open problem, right? Right. I mean, a problem where use anything you want, right?
Yeah.
Source transforms are easy ways of reducing a circuit.
I tried source transforming quiz A, problem 1, thinking that was the way to do it, and I kind of got stuck on that.
You're way. I mean, you don't need a source. You got the currents. You already got the currents. You don't.
Yeah, I saw the current.
You got the currents to the load. You've got everything you need.
Yeah, I ended up figuring it out. I was way overthinking problem 1.
All right,
Sorry, is source transforming what we did Monday before the quiz?
Yeah, and I hopefully I try to answer a question to show you that. It was great the way it would develop because somebody asked a question, and then the answering of the question is a thing that was allowed me to do source transforms. By the way, source transforms are your friend. They help. They can reduce a circuit's complexity in a heartbeat. If you'd like me to, I can take you through a problem on it to show you just how fast. But I think I already did, didn't I? 1 or 2? I'm pretty sure I did.
I think you did 1, but if we could maybe do like a quick one, that would be really helpful. At least.
Yeah. Hey, let me call my grader. All right. I want to make sure because I thought that those grades were in, and I apologize because I always try to get the grades done before the next lecture. I don't ever like waiting. So give me 1 second on this one to call him. He probably was here, but he has a class possibly. Anybody, by the way, in this, I'm calling him, got any information that's beneficial to the class about COVID-19 or anything else around the area?
Isn't Auburn like 5th in the nation for most COVID cases?
I don't know. Where'd you hear that?
A friend of mine was just telling me that, yeah, it's real bad. Like,
Yeah. All I heard is that it's a
UAB, I think, is in the lead for the most COVID in the country.
Is that per 100,000 people, or how, when you say in the lead, but what standard?
Total cases.
In a county?
Like since the start of the semester.
Yeah, I think like cases reported to the university.
It might be. It might be.
I know.
I can't hear you. You got to unmute yourself.
Oh, sorry. I know there's supposed to be a spike in cases like after Labor Day because of Labor Day and like everyone doing stuff.
Is that yeah, that would make sense.
We'll see.
Let's just stay, don't do anything. Let me put it this way. Go play golf, go fishing, do something outdoors.
I ended up getting exposed because my girlfriend's roommate went and partied. So it's not like there's much we can do, you know?
Oh God. I'm sorry. I'm very sorry. I mean it.
Yeah.
Oh, I got a story about a couple of friends at church got it. A handyman came over to their house to fix air conditioning. I think it was air conditioning. It's one of them things, the guy didn't wear a mask and stuff like this. Next thing they knew, they both had, thank God they're both fine now.
Yeah, I live with like 7 roommates and 5 of them have tested positive in the past week.
Move out.
I tested positive too.
Oh God.
So
Hang
I
on.
also I have a question about that. I'm gonna call him if he gets through. Okay.
Hey, I'm sorry that you are you over it? You still running a fever or anything?
I've never had a fever, but I've been still having coughs and stuff, even now.
Don't come to campus.
Yeah, I don't have any proof, but
I don't care.
I
Just
know
don't
that
come to
we
campus. Don't
the
come to
quiz
campus.
Friday.
Don't come to campus.
Would it need a proof of that? I can try getting one, but should I get a proof for the quiz on Friday?
I'll figure out something. All right.
Okay.
I'll figure out something.
I
Hold
can
on
people.
for one sec. Tell you what, Evan, when you're done with this with me, email me your phone number. All right. You got a cell phone available? All right. Make
Yes,
sure
I can email
3810 Evan, and then so I know it's from you.
Okay.
I mean, you don't have any idea the volume email I'm getting nowadays.
I don't doubt it.
This course has caused me more problems than anything I've ever had in my life. I've got email from the administration, from student conduct, from God knows who else, and I'm frankly getting fed up with this. So please, if they contact you, make sure you contact them back, or else your grade's not going to happen. Now, where was I? He's in a class right now, but I'll take care of this my way when I get done with this. I can make those grades appear one way or the other, I believe, unless I've been locked out of my own account. But overall, I'm going to level with you. There's some excellent papers, 10s, and some people made dumb mistakes. And you'll see that. And then there's some people that really, unfortunately, had no clue. So you'll find out, but I have to I'm sorry I don't have them. They weren't available to you. Any other questions? By the way, listen, I don't pretend to be, I'm not in the circles right now that knows exactly what the university is planning or anything like this. I'm planning for anything. If we have to go all online, I'm ready for it. If we're allowed to go back to testing on campus, I'm ready for that too. And I hope you are too. What I will encourage you not to do is assume after Labor Day we're going to go all online. Don't make an assumption you're going to regret. All right. I have seen people do things like that to their harm, or assume it's going to be all here all the time. I can't say either one. I'm just aware of some of the discussions that people are having. A lot of people want to stay here because of football. Right? I mean, these are not students. The merchants, of course, want you here. Right? But others are concerned about the safety of everybody. So there are forces at work. And I am not there seeing how the scales are weighing out. I'm just telling you, be ready for anything. And I do mean that too sincerely. Anything about, you asked me about doing one, right?
Yeah, I was just asking if we do like one source transformation problem. It doesn't have to be a long one. I just need like to
No
see.
problem. If you've got one in mind, we can do it. Otherwise, I'm going to pick one.
I don't have one.
I do. How about 72? The camera's, hold on. How about 72? And if you, I don't remember if we did this one or not. I'll try to get close.
No, we did 72.
All right, how about 73? Oh, that's 7. We can do source transforms then if you want. You want to do 72 or 73? Unless you got a better one. You want to go back? Huh?
I don't care.
I mean, look, this one says do source transform 71. Can you see it?
Yes.
All right, remember for source transforms, the one thing you don't do is transform the thing you want the voltage across, which is the 3K here, right? Can you see that 3K?
Yeah.
All right, now look, you see how this is a voltage and source in series with the current? How about if I draw that and go through it, guys? Hopefully everybody will see this. This is 71. So they've got 4 milliamps. I'm just redrawing.
Need to move the paper up.
Yeah. 4 milliamps. By the way, is Alabama still in session, aren't they?
I think so.
I'm asking because I don't know.
I think they are.
That's probably a good college to look at if you want to figure out what Auburn's going to do. But I don't know if they are or not.
Aren't we supposed to be smarter than Alabama, though?
Right now, it ain't about smarts. It's about decision-making that has to do with the alumni, the board of trustees, the president, and probably Harris, the health official in the state of Alabama. They're looking at sheer numbers in the hospitals and the expected numbers in the hospital beds nearby, because the minute they're expecting an overflow, they're going to shut it down, guaranteed. And it has nothing to do with intelligence. We could be MIT, and they would shut us down. That's another thing I'm going to tell you, that they don't want anybody to know what they're thinking because they always worry about self-fulfilling prophecy. Then it'll happen. You know, never tell people what you're worrying about because then it'll happen, kind of deal. All right, now what I'm going to do is say the last thing you want to do is put the 3K resistor back on. That's where it was. I removed it on purpose. You follow me? Y'all with me on that?
Yeah.
All right, now look, you see that these two make up what we would talk about as being a voltage source in series with the resistor, right? I want to break that out, make sure you see it. Here I have minus to plus 12 volts, not your standard way of doing it. And then I have 6K. Now, it's not bent the way you'd like it. You would like it bent this way so you can clearly see it. It's straight, right? I mean, this thing's just straight, and y'all see? Here, I've bent it on purpose so you can see, correct?
Mm. Yeah.
All right, what's that equal to? Well, isn't that equal to a current source, right? Where the current would be minus 12 divided by 6K, or the current really would be in this direction, right? It would be 12 over 6K, or 2 milliamps going down. Do you all see that? It's going in that direction. Can everybody see that, people?
Yeah.
I got to make sure everybody can.
Yeah.
Okay. It's going down, right? Because of the negative sign here. Current's going to go down, and it's in parallel with 6K, right? You all see that? Now, I don't want to go quick, but I want to make sure everybody can see this, right?
Mm-hmm.
Now take a note here. That's this. This is this, right? So I can replace this right here to here with this. So I'll redraw the 4 milliamps. Now I've got 4 milliamps here. All right. Now I'm going to put in the 2 milliamps, right? That's going down. All right. Then I'm going to put in the 6K. And now I want you to notice that I've gone ahead and I've basically transformed those 3 elements on top that I've circled in blue. Do you agree with me, class? Please take a good look. Do y'all agree with that?
Yes.
Yes.
How many people do we have on here? Can anybody give me a count?
14.
All right. Well, you know, I'm sorry that no matter what I do with an office hour, I'm going to discount at least a third of the class. I'm glad you guys are hanging around. I really don't mean to run into, have people like compromise other people's time. But unless I do the office hours after 5, and that gets into a whole different situation, I get in trouble for, because people have jobs, have all sorts of stuff. I'm trying to do it during our regular business hours between 8 and 5. And if you got a better suggestion, I'll be happy to do it. But no matter when I do it, if I do it Tuesday, Thursday, they got labs all afternoon. And the morning, they got some weird classes. So no matter what I do, I'm in trouble with a class this size. And nighttime is not something that people like. I found that out. So I'm just getting back to this. This is the best I can do. It's recorded, so at least people have a shot at seeing it if they're not here in person. You all see I can add these 2 together? Do you agree with me? I got 2 and I got 4, that's 6. So I can take these 2 and make it simply a single current source. And that would be simply 6 milliamps down in parallel with 6K, right? And that would be across these 2 points right here. Do you agree with me? Now, can you see that this could easily transform into a voltage source in series with 6K, class? Sure. I would take 6K times 6 milliamps. Notice it goes downward. So that'd be a minus to plus 36 volts in series with 6K, right? You know, I hope you have the problem in front of you. Amanda, I think you asked about this. I'm to here. Now I'm just going to put that 3K on, okay? You with me? I'm to here, and I'm going to add that 3K. Do y'all see what I've done?
Mm.
Now, can you see the 3 and 6 can be added right there? Guys?
Yes.
Yeah.
And Gabby, can you see this? Are you having trouble seeing this or not? It's hard for me to tell.
Yeah, I can see it.
It was looking like you were struggling to see it. I got to make sure y'all can see that. So that's just 9K and 36 volts that way. And I'm going to redraw it to right here. All right. So now I've got plus to minus 36 volts, 9K. There's where I'm going to put my load in a second, and then I've got plus to minus 12 volts. Now, I didn't put the load back in, but I want you to take a look at this. Do you all agree? But that's really where I'm at. Agreed, class? Please make sure you take a good look at that. Now, what can I do with these 2 sources? Think about it. I've got negative, from here to here, it's an increase of 36, then an increase of 12. Can I add them together and make it one source? Sure, it'd be one source of 48 volts, correct, class?
Mm-hmm.
Let me do it right here. So I'm gonna have 48 volts. Then I've got 9K. And then finally, now I took out that resistor I wanted the information across, the current or voltage. Now I'm going to put it back in. I only did that to make sure your eyes were on the problem, not other things. We're worried about transforming everything else, not that. Now I put the 3K back in there, right? And they wanted is 271. They wanted the voltage across this 3K, all right? Call that V out. Do you agree with me, Klaus?
Yeah.
So what's it going to be? And I can write it down right here. It would be the source voltage. You see how that's a negative 48, right? The voltage is negative terminals on top, correct, class? Then it's times what? Times the resistance you want the voltage across, 3K, I'll drop the K, over the sum of 3 plus 9 or 12, right? Okay?
Yeah.
And then we have divide by 3, I got 1, divide by 3, I got 4. 4 into minus 48 is 2 into 24 is minus 12 volts, right? You agree with that? How many see this?
That's it.
Okay, I hope that addressed your questions. And remember, this is not that difficult. The thing is, do a fair amount of problems so you feel comfortable. All right, and also read what the problem wants. All right.
Okay, really quickly. So at the beginning, when you go from the 12 volts to the 2 milliamps, that's because the 4 milliamps, when you go into the, it goes into the node, right? And there's two like things from it. That's 2 milliamps in each one. And that's how you know that's 2 milliamps.
I'm not sure about the 2 milliamps, but let me try to address this. This is my starting point. You see it's 6K in series with 12.
Mm-hmm.
Now I know that that's a series voltage, a voltage in series with the resistor. So I can transform that to a current in parallel with that resistor, right? Right? Series voltage, voltage in series with the resistor is the same as current source in parallel with that resistor. Got me on that?
Okay.
These two are identical. These points here and here are the same as these points here and here. Now the reason, my motive for doing this, see, I got a current source over there. So if I get another current source in parallel with it, I can add them together and reduce the number of components. Whenever I do a source transform, I'm trying to reduce the number of components by 1. I had 3. By the time I'm done, I'm going to have 2 down here, right?
Okay, then how did you know it was 2 milliamps?
Here? All right. Well, because this current here, that I call it right there, I source, is equal to this voltage divided by that resistance, right? That voltage is minus 12. The resistance is 6K, right? That's minus 2 milliamps or 2 milliamps going down, correct?
Can you push down the paper?
Sorry. What I'm saying is this current right here would be this source voltage minus 12. Typically the current's going up. That current going up would be the source voltage minus 12 divided by the series resistance, 6K. That's minus 2 milliamps, which means it's 2 milliamps going down, right? And the resistor just goes in parallel.
Okay, got it. Thank you.
Sure. That's the whole essence of source transforms.
Can you only combine current sources when they're in parallel and voltage sources when they're in series?
Absolutely right. That's exactly it.
Why is that?
Well, voltage sources are like pressure. So if you had an increase of 5 pounds of pressure, then another increase of 5 pounds of pressure in series in a piping, the total pressure differential would be 10 pounds, right? Per square inch, say per square. It's the same thing. It's electrical pressure. Now, currents are like flow rates of water. You got 3 gallons per second this way, 5 gallons per second this way. They're both parallel and both flowing into a same pipe. They're equivalent to what? The sum of the two into one pipe, right? Current is like water. And you know, that may bother some people, but it's the best I can do. I always think of current as like incompressible fluid, like water. The pressure in the piping is like voltage. It's a really good analogy.
As an IE, I really don't get those analogies you give, and I don't know if I hit everyone else in IE.
Are you an ME?
No, never makes sense to me either, John. Don't worry.
Are you MEs or what are you? Or AEs?
Industrial.
Oh, well, yeah. MEs do a lot of stuff with hydraulics and piping an incompressible fluid flow, and they're used to thinking in terms of pressure heads and water flowing. They just are.
No.
Then it's like this, really though. Currents are things moving, and it's a certain amount of whatever the material is per second that's flowing across a point. So if you got those things always in parallel, they would be additive. Voltage is always in series because it's like a pressure difference. I don't know what else to tell you. With industrial systems, you do flow rates though, right? Process rates and all that?
Yes.
Well, I'm not sure if I got a good analogy for you from industrial, because I'm always thinking industrial has to do with the number of packages that are coming out the door per hour or something like that, and or the net profit per hour or something. It's not about what's actually coming out the door. But you know, if you got two plants, if one's producing 10 packages an hour, and another's producing 20 packages an hour, and both packages are going in the same truck, then you would add up the amount of packages. It'd be like the same thing with currents in parallel. You would add them together. That's as good as I can do. It's not very good. Okay.
So do you have one for materials?
Huh?
Do you have one for materials?
Oh, don't even go there. Come on, man. Ask your friends.
Dr. Baginski, I just wanted to confirm. You said voltage in series with a resistor equals current in parallel with a resistor?
Yeah, but remember what a source transform is. And I hope you all caught me on that one. What is a source transform? The whole idea is this. If I have a voltage source, V naught, in series with resistor R, and I have two terminals here, I want it such that anything I put across these terminals, I get the same response. I'm making an argument this is equal to a current source where the current I is just the voltage source divided by R, taking that R in parallel with it, and then saying these two terminals right here are the same as these two for all intents and purposes. Anything I put across here will have the same response as anything I put across here. That's the argument. And I'll prove it to you. I mean, I can do it abstractly, but if I make V naught 10 volts, let's just do this. And I'm going to make R 20 ohms. No, I'll make it 5 ohms, all right? I'm saying this is identical to a current of 2 amps, right? In parallel with 5 ohms, right? And anything I put across either of those terminals will draw the same current. I know it's out of focus. You agree with me?
Yes.
Come on. All right. So let's start by doing an experiment. First, we're going to put a short circuit. When I put a short circuit here and here, how much current flows here if it's a short circuit? If that's a short circuit. What's the resistance?
0.
0. So how much current would flow?
0.
10 divided by 5. No, short is this, right? It's a conducting path. So it would be what? 10 divided by 5 or 2 amps. Agreed?
Yeah.
Mm-hmm.
All right. What about if I put a short here? How much flows? All of it,
Nothing.
right? Yeah, because if you do current division, you would take the opposite resistor over the sum of 5 plus 0, or 5. 5 over 5 times 2 is just 2, right? And it would flow this way. You all agree with that?
Yeah.
That's if it's a short. All right, now try it. Make it 5 ohms. What if it's 5 ohms and this is 5 ohms? How much current flows here if it's 5 ohms? Go to this one first. Class? If this is 5 ohms, right, how much would, I don't know why that thing is not focusing. Here, sorry. I'll have to mess with that later. All right, if that's 5 and this is 5, how much current flows? Class?
Would it be 1 amp?
Yeah, but I mean, the reason would be 10 volts over 10 ohms is 1 amp, right? Right?
Yeah.
I mean, show me the physics. All right, how about here? If that's 5 ohms, you're going to use current division, right? So it's going to be what? The current flowing into both of them, which is 2, right? And then you're going to take the opposite resistor, which is 5, over the sum of the two, which is 10, or it's going to be 5 divided by 2, or 1 amp, right? Are you with me? Identical responses. Doesn't matter what the resistance is. Go the next step. All right? Remove this. Make it an open circuit. If that's an open circuit, how much current flows? If that's removed, how much current flows? It's as obvious as it seems. Class.
0.
Huh?
0.
0, right? Nothing, right? If this is an open circuit means it removes a path for current to flow. It's 0 as well, right? Now, you can go ahead and put any arbitrary resistor there and prove, in fact, that this is identical to that in terms of response. And that's the reason it works, okay? Now, again, everything we're doing here is based on basic physics. Your first electricity course in physics should do you justice here, because everything you're seeing is nothing new from that, other than now we're assembling things and we're using something called Kirchhoff's law, which is nothing more than something that would be called, what is that? The minimal energy principles in physics. And I'm not going to even try to explain that to you from a physics perspective. But there's nothing really new here. Are you with me? The theorems are, I mean, it's a clever little source transform stuff you don't get in physics, but they're the same basic principles and they're nothing difficult. Okay.
So what if you like muddy the waters a little bit and you have a current source in parallel with multiple resistors? Can you simplify that into a voltage?
Matter of fact, if somebody wants to jump in here and help me, please do. So he's saying if I have a current source, how about if I just call this I naught, okay? You good with that?
Yeah.
Now I'm going to put a resistor here. I'm going to give it a value, 10 ohms. I got a 10 ohm resistor there that I want the current through, all right? I want that current. But I also have, and help me out here, maybe you want to draw on different, I'm going to have a resistor there, another resistor there, and another resistor there. Is that enough resistors?
Yeah, plenty.
All right, let's make this 20, make this 5, make this 100 ohms. So how do I get this current if I've got that? Assume I got I naught, make I naught 10 amps. What are we going to do, anybody? Somebody I'm sure knows this. Maybe you don't want to tell me. Well, let me ask you this. Can all these be reduced to one resistance?
Yes.
Yeah.
Couldn't we say the sum of these three, call it R equivalent, would be equal to 1 over 1 over 5 plus 1 over 20 plus 1 over 100, right? And if you want to do it the hard way, it's what? 1 over, well, if I take a look at this, that would be 20 over 100, right? Plus, and then 20 goes into 100, 5 times 5 over 100 plus 1 over 100, right? And then you would get 100, right? Divided by what? 26, right? You got to take the 100 on top, right? And that would be in ohms. I'm not going to bother, but do you agree we get one single value for that? Agreed? 3 in parallel? So we take all 3 of them and put them in parallel. Now, whatever that is, and I don't care, that's what we get. Now I come down here, and I hope this thing behaves. And I go ahead and I put this like this. Now I have 10 amps here. I have 10 ohms here. And I wanted this current, right? But now I've summed those 3 and get a single resistance value. And that resistance is 100 divided by 26, all right, ohms, whatever that is. 100 over 25 is 4. So this is a little greater, a little less than 4, 3.9 something, right? Agreed, class? All right, so if I want this current, what do I do? Class? You agree they're in parallel first, right?
Yeah.
You always take, and they're in parallel, 10 is flowing into them. So take the current flowing in, then take the opposite resistance, the 100 over 26, and divide it by the sum, 100 over 26 plus 10. And that would be the current flowing into the 10. Do you agree with me?
Yeah.
John, you got it? Gabby, do you see this? You good? All right. I want to make sure you see this. It doesn't matter if there's 3, 4, 5, 6, right? I got a question for you. Here's a really tricky thing I could do. I get a nasty note if I did it, but it would be fair game. What if I put a short there?
We can't see it.
Oh. What if I put a short circuit like that? Now how much current would flow through I-10? Well, what's the voltage across at the 10 ohms if that's a short circuit?
Well, 0.
If it's 0, how much current can flow there?
0.
Matter of fact, the short circuit in parallel with anything is still 0 ohms. A short circuit is 0 ohms. Do you follow me? It's bare wire. If you got 0 ohms in parallel with 1 ohm, it's still 0. 0 ohms in parallel with 100 ohms is 0. 0 in parallel with anything is still 0. Do you follow me? It's like multiplying by 0, because resistors in parallel, if there's just 2, it's the first times the second. 0 times something over 0 plus something is always 0. Got that?
Yeah.
And that's why the minute you see a short circuit, the current through here is 0. All 10 would go through that short circuit. Got that, class? And
Because it's the path with least resistance, right?
That's the way they'd say it, maybe in beginning physics. Yes, it is. There's no resistance. It is the least. If it's 0, it can't get any less than that. You with me?
So there's only no current going through that unknown I because
all the
current would rather go through the other one.
Right. As a matter of fact, there's no voltage difference, right? So none of these resistors will have current. All the current flows there. It's a short path. Short circuit there. There's no reason for it to go here. There's no way to develop a voltage if you have a short circuit. Short circuit eliminates the possibility of voltage being developed. A voltage difference. Got that?
Because the nodes have the same voltage on either side of all the resistors.
Yes. There's no difference, right? Now that's not meant to be a dirty trick, but it sure finds out who understands stuff. Usually if you go for interviews, now MEs will, Tom Birch tells me things, so does a few other people in it. They tell me when you go for an interview these days, as an electrical engineer, they ask you mechanical engineering problems. I mean, when I say mechanical, statics, right? Sum of the forces is equal to 0. Dynamics, sum of the moments is equal to the mass times acceleration. Sum of the what? Moments of inertia is equal to the angular moment of inertia times acceleration. Those kind of things are fundamental. They expect you to know. They may ask you some basic thermodynamics. All engineers get this. In the fundamentals of engineering, you'll see this when you take your exam. They expect you to know circuits and stuff like that very well. They want enough breadth so they have confidence in you. If you go to Intel, my wife worked there for a while. If you go, they want to make sure you've got a solid grounding in engineering is what it comes down to. Then they want to make sure you're smart. So that nowadays they give you something that's fundamentally a IQ test dedicated to like engineering concepts. And because they don't want to hire people that aren't very bright, and they find out real quick if you're what they want. Now, you know who's notorious for doing this, by the way? I bet you can guess.
SpaceX.
What is the best company on the planet to work for in terms of benefits that you know of?
U.S.
And
government?
don't say your dad's. What?
The U.S. government?
No. I'm talking about pay and benefits. I'm not talking about security in terms of your job. Google. And you know what Google does? Go look it up. They hire only the brightest and the best. I mean, if you aren't basically a 4.0 coming out, I mean, if they like MIT, And somebody, when you go out there and get in the interview and testing, I'm talking about entry level now, that you're the very best, I don't think you have much of a chance. But if you do qualify, then you're going to be treated like a king or queen. Now, Apple does that too, to some extent. And I understand there are certain high-tech companies out west that do it, certain companies around here, and their hiring practices are very, very selective. But they're the people that are exploding. They don't need people to run errands. They need people to design and come up with brilliant ideas. Have you ever heard of Bell Labs? Anybody? Long ago, there was a company called Bell Labs. It's where Bell Telephone came out of. They had more Nobel laureates in their buildings per square mile than any place on the planet, including Caltech or University of Chicago. They bred Nobel laureates. It was amazing. And they had that kind of a hiring practice. And they would almost exclusively in Cherry Hill, in Jersey, would only hire people with PhDs that were like super, super geniuses. But it led them to develop so many advanced systems in telegraphy and the telephone system and all sorts of advanced systems. And then the government broke them up, which is a dumb thing to do. But at that time, they had like a critical mass of geniuses. You know what the Manhattan Project is, anybody?
Nuclear bomb.
It was the very first nuclear weapon, and every other nuclear weapon since then, I'm told, was designed based on that. Nobody's ever come up with another original. Now, the interesting thing is the way they got that done was they took a critical mass of some of the most brilliant people in the world, physicists and engineers, and they literally locked them away and gave them an assignment. And to make matters more interesting, there were all sorts of incentives, but they came up with it. You put the very best and brightest into an area and let them loose with some incentive to do it. And it's amazing what they can come up with. Things like that don't happen much these days, but Google may have something with their drone delivery system, and so will, I think, Amazon. And artificial intelligence is something you people are going to see in your lifetime. And I think some of these big companies are driving it, not the government. But I don't know that for a fact. It's speculative. I've been listening to a lot by a guy named Dr. Jim Tour, who's a genius in synthetic organic chemistry, and another couple people. And the stuff that they're coming up with is starting to, make me feel like I'm going to be too old to appreciate a lot of this stuff, but it's happening at a rapid rate. You're going to see it, though. When I was where you were, we were just at the advent of VLSI technology, very large-scale integration. Our calculators still had the red LED lights. We didn't have LCD and stuff like that. This is my grader. How about if I get to the grading? All right. Make sure your grades get up. Okay, guys?
All right.
All right. Take care. Hey, man, hang on for 1 second. Their grades aren't up. So did you put them up?